Hi guys, welcome to Learn Electronics Repair. I have another power supply here. This is an 800 watt Mars Gaming. We get quite a lot of this brand on the island here. And it is faulty. So I'll show you what's wrong with this one. Apparently this one is blowing fuses. I've connected it to the light bulb, the current limiter up there. Let's power this up and let's see what it actually does. Well, basically the light bulb comes on and stays on. Yeah, it actually stays on at the same brightness. I think on the camera the auto exposure came in and made it look like it went a little bit dimmer, but it doesn't. So this has a short, and quite possibly a short on the high voltage side. Because there's a short and the light bulb is on full, very little voltage was actually getting into this. So there won't be a high voltage charge in the capacitors. We don't need to worry too much about that, but we will have to open it up and have a look to see what the problem is. We'll get in here and we'll have a look. It's probably worth fixing this if it's nothing expensive that's gone wrong with it. 800 watt power supply is quite useful. In fact, I do have a use for this, so let's see if we can get it to work. It may end up waiting parts, because if the main switching MOSFETs or bipolar transistors have gone short, I probably don't have any at the correct time. So let's see, hopefully at least we can diagnose a fault if we don't have the parts to fix it today. Well, that came off easily enough. These are always glued in, they're a bit of a pain in the butt. And the glue's gone hard and brown. It's out. If you don't hold the socket down with something like this, that will come off the board usually. Right, here's our power supply. We have two heat sinks and we have two transformers. So, like the last one I was looking at, I can see 3 octo isolators. That makes me think or believe that the controller for the main power supply is on the high voltage side. This is the transformer that's driving the main output. That is rather small for an 800 watt power supply, I will say. This is the standby supply. That will be the chip that's driving that. This will be the monitor chip. You can see this board can either have an 8 pin or a 16 pin, or is it 20 pin in there? 18 pin. And this is the standby voltage coming out here. Yeah, that's what we basically have. I will take the PCB out and let's have a look for some shorts. I've removed the screw so the PCB now is loose. I'll have to remove this clip in here that's effectively, there we go, effectively, yeah, keeping these wires in there, that's what I meant to say. Okay, and then we have the mains power coming in. I can see there's a white one here, so this will be the filter. Yeah, then it looks like it goes down here. This is a switch. So this white one comes directly to the PCB. We can disconnect this one. There won't be any high voltage on this for 2 reasons. One, I obviously have a short, so nothing's getting in here in the way of voltage to the capacitor. And 2, the mains is on the other side of the bridge rectifier. So even if there was a high voltage charge in the capacitor, there would not be any voltage here. As long as it's not plugged into the mains, of course. Just a bit of fresh solder on there. Okay, so that's that one, and then the other one goes to the other side of the switch. Okay, I think I can get down here. Yeah, so I have the 2 wires disconnected where the power comes in. This will now come out. Just need to get the wires through the gap. Yeah, there we go. Right, Here's our power supply. Let's look for some short circuits. First place then, and the most obvious place, so obvious you'll forget it. Put that on one side. Do we have any shorts on this filter board? There's a capacitor here, could go short. Not particularly likely, but it could, so let's check here for shorts. And no, that reads open circuit, that's how you'd expect it to read, so there's no problems on there. Second one then, mains power coming in, these two wires, do we have any shorts? Yes, we have a short circuit. So the short is on the input here somewhere, there's a fuse. The fuse hasn't blown. The fact we're seeing a short would tell me the fuse hasn't blown, it hasn't. So there's something right on the input of here that is short before the bridge rectifier, or possibly the bridge rectifier itself. Let's have a look. The bridge rectifier is here, 1, 2, 3, 4 pins. These are the AC terminals, yes, we have a short, so you shouldn't expect to see a short there. Let's go from the AC to, oh yeah, that's one of the diode junctions. We have a short circuit bridge rectifier here. That's the first thing that we have. So that means the AC has got further into here. Yeah, and there's a short on the output of the bridge rectifier as well. But the first thing we need to do is remove this bridge rectifier so we can trace further in. If we leave it in there, the short could be in here, so we'll just see a short further onwards. Let's remove this. I'm waiting for a new handle for my vacuum desoldering tool, so we'll do it the other way, which is solder braid. I say the other way, there would be other options too, but let's try it. So it is wicking that up, but I'm going to put some flux on to help it. Again. Yeah, you can see that's come nice and clean now. So I have made a whole video on solder braid. If you watch it, you will know that this is the way to do it with flux and with the right sort of braid. Okay, fell out of the board. I didn't even have to pull it out. Yeah, it's there. Let's see if the shorts are actually in the bridge rectifier. The fact it was showing short on the AC terminals tells me it will have. Is it marked? It's probably rather hot. Yeah, it is marked. You see, plus and minus, okay, so we know where plus is. Normally speaking, plus is where this little angle thing is, if it has that type of enclosure, packaging. So we have a short. Our bridge rectifier is completely short circuit. Okay, that needs to be replaced. Let's go a bit further down. So, obviously now if we go to the AC, then we should not see a short anymore. Yeah, very high resistance climbing up, mega ohms. What about across the output? That's also reading well into the kilo ohms. So it's possible just this is short. There's certainly no short circuit the other side of it, nothing obvious. I mean, we could have a situation where the main switching transistors are being switched on permanently due to some fault in the driving circuit, and that, if obviously when you plug it in, would draw a massive current through the rectifier. What I'll do with this one now, let's see if we can find a suitable replacement. We'll put that in, and then we'll power it up with the light bulb again, and let's see what happens. The bridge rectifier is GBU806. I'm thinking, because these numbers sometimes make sense, this will be an 800 volt 6 amp. If this is an 800 watt power supply, it needs to be at least 4 amps going in at 220 volts to give 800 coming out, basically. And that's assuming almost 100% efficiency, which, to be honest, a switch mode power supply can get reasonably close to that. So I wouldn't be surprised this is an 800 volt 6 amp or a 600 volt 8 amp. Let's have a look. Well, I think we have a data sheet. Yeah. Any of these actually data sheet links? All data sheets, pretty good one to go to. GBU806. It's an 8 amp, and I'm getting probably 600 volt then. Let's have a look. 8 amp. Yeah, 6 is the voltage. Okay, so 600 volts, 8 amp. Let me see if I can find something suitable. Well, we have a GBU 606. These are all pulls out of things. There's another KBU 606, which I'm guessing is a compatible. This one is another GBU 606, and this one is a 738. So these are actually lower powered. This is an 8 amp. These are 6 amp. Let's have a look at this one. This KBU 8K. That one there. Let's see what that is. That might be 8 amp 1000 volts. Let's look. So KBU 8K. See if we can find that one. Well, this one is 8 amp 1000 volt. Yeah, 8K. Is it 1000? No, it's 800 volt. Okay, so 800 volt, 8 amp. So that one is quite suitable. I will put that one in. And I think actually the original type, or even these type, I think I'll just order some because I don't have exactly that in stock. If I found a short circuit one, I'll probably find another one. And if they're not expensive, that was the time just to put some in the shopping cart, even if I have a replacement now. I'm just looking now on AliExpress, the GBU 806. I can get 5 for €1.29 with 22 cents postage. The GBU 8K is 176. But I've noticed we have the 808, which is the 800 volt, and we have the 810. So I think actually I'll order these ones because the 1000 volt can be used to replace any of the other ones. 8 amp, 6 amp and 4 amp, I would think. Really this is kind of like a universal one and cheaper than the GBU 8K. But the same specifications. So I'm actually going to put them in my cart now, and then the next time I place an order, they'll be sitting there waiting for me. At that price, guys, it just makes perfect sense to buy some. If you need one on one occasion, you probably will again. Obviously, this is a pull, so we need to test it before we use it. We'll go to diode mode. Bridge rectifiers are very easy to test with the multimeter. So we have the two AC terminals, okay? If we put the black against the AC terminal, either of them, we should see a diode junction to the negative. 490. And the same from the other one. Okay, so that's the two diodes from either of the AC legs going to the negative with the black on the AC. With the red on the AC, we should see open. Nothing there. Nothing there. Now we go the other way. We'll keep the red on the AC. We'll go to the positive terminal. And we should see a diode junction. Okay? And another one. And again, with the black on the AC to the positive, we should see nothing. So black on the AC terminals should both show a diode going to the negative. and red on the AC terminals should both show a diode going to the positive. Across the positive and negative, if you go with the red to the positive, so think like red is positive, it should read open circuit. But if you go the other way, effectively the reverse biased direction, this would never happen in reality. So the positive to the negative, you'll read like 2 diodes in series, 0.9, roughly the same as 2 diodes. So that's a good bridge rectifier. Let's put this in and then let's see if it works. The PCB is nicely marked for us actually. It shows the little corner there, it shows positive and negative. But if it didn't, it wouldn't be hard to work it out. You just measure from the negative end of this large capacitor, and whichever pin it goes to on the bridge is the negative end. Positive end of the capacitor to the positive end. So it's very simple to work it out if you didn't make a note of it when you removed it, or it wasn't marked properly. Okay. So we just need to get this to fit in here. The leg's a little bit tight, but I'm pretty sure I can get it to go in. Yes, with a little bit of pressure, I did get it to go in there. We can solder it in, then we can just test again in the circuit to make sure we have the connection properly. Okay, there's our bridge rectifier soldered. We can do the same test that we just did with it in circuit and we'll read the same. So, negative to either of the AC terminals should go to the negative end, which is here, this should read open both ways across the 2 AC, open, open. Positive from here should go to here. And you can see I don't have it soldered. I don't have this positive end soldered. It's not sticking to the board far enough. Let's just see if I can fix that. I couldn't get a good connection, so I've removed it again. I'm just using, this is like the square section end of the soldering tool. I'm just going to make the holes a little bit bigger because they're very close. I mean, you could just use a Dremel with a drill bit just slightly bigger than the hole. But I think that this will actually probably do it. It's a single-sided board, there's no wires or anything like that. So I don't think this would be a problem doing it this way. You know, maybe I'll order some of these and I'll order some of the other bridge rectifiers as well, because they have like a narrower leg, and in another situation it might be difficult and it's only another like €1.30 or something, so I'll have 5 of those as well. Yeah, now it fits directly in the board, yeah, no problem. Let's fit it again. Okay, that's soldered. Now it should read just fine. Let's have a go. So, black to the AC, diode. Notice the diode junction voltage has dropped slightly. This is because it's hot. Can you see it climbing up? As it cools down, you often find that with semiconductor devices. It's normal. From here to the positive. Yeah, we have a good junction now. The 2 AC will read open, and then with a black to the positive we should read like 2 diode junctions. Okay, that's actually reading like a diode. That probably is something further in the circuit, or there is some other problem further in the circuit. But this way round, so this is the positive terminal, and with the red lead to the positive we don't see anything. With the black lead to the positive we're reading a diode junction, but that polarity will never exist when the board's powered up. This will always be the positive end, so that's probably perfectly fine. Let's give it a bit of a clean because it's a high voltage circuit, and then let's try it. That's nice and clean now. While I was waiting for that to dry, I went back to AliExpress. I realised that the ones I ordered should have, according to the picture, these type of legs. But while I was in there, I spotted I can get some GBU 2510, which look to be similar. They may be thicker legs, which are 25 amp 1000 volts, and they were like €1.55 for 5. And I thought, you know, I'll order some of these as well, and then I have a good range of bridge rectifiers in stock for €3, and they will probably replace just about anything. If you think that's being a bit excessive, then I suggest you just add €3 to the cost of the repair, and I don't think the customer will be too unhappy, and you get yourself a handful of useful bridge rectifiers. Let's see now if there's anything else wrong with this power supply. If you found a fault like this with a short circuit bridge rectifier, usually there's a short somewhere else further down the line that's caused that to happen. I can't see a short on this one, but I am suspicious of it. So I'm going to power this up connected via the light bulb. Now, this light bulb, basically that one is a 65 watt light bulb. It's a halogen one. You can't use an LED light bulb for this. It has to be an incandescent or a halogen. And all you do is you connect from the live to one end of the light bulb and the other end of the light bulb to your device. So the live is coming via the light bulb to here, and then this one just goes to the neutral. Mine has a switch, so I can actually short the light bulb out just by closing the switch. The light bulb is shorted out, and then it's just connected directly to the mains. I have another one which has 2 amps in parallel, giving me 160 watts. That's probably more useful, but this 65 watt one works very well. So there's nothing mysterious about these light bulb current limiters. It's just a light bulb in series with one of the AC lines. And it doesn't matter if it's the live or the neutral. It makes no difference. Let's switch this on now and let's see what it does. Well, the light bulb flashed and went out, and it's working. Let's just get the ATX analyzer where you can see it. Here is the analyzer. We can switch the light bulb out now. So I've just pressed the switch which just shorts the light bulb out. We know it's not going to explode or go pop or any sparks and stuff to happen, any magic smoke. Or at least we think there isn't going to be, because if that was drawing a lot of power, that light bulb would have stayed on. Okay, let's try it. Okay, so it's running, but all the output voltages are low. So there is still something wrong with our power supply. I'll put the light bulb back on. Let's have another quick look. So actually, we only have 5 volt standby. Looks like we have nothing on any of the other voltages. It's saying low. I can use my multimeter and see exactly what we have there. While I was getting that ready, something smells like it's getting hot on here. Yeah, I can smell something that's getting warm. Okay. Something like an electrical, like something wants to burn. I have the light bulb on current limit, so not much current can come in here. What I think we have, it's gone away again now. I've switched it off. Something was obviously getting hot. Let's have a quick look. I won't leave it switched on so long this time, okay? So I will check whether we have any voltages coming out of this. That's all, apart from the standby. Well, I was just going to do that. You probably heard the meter actually. In fact, you saw it. It looks like we have some shorts on the output. Let's disconnect this. So this appears to have multiple faults. Let's go into the black and let's have a look. Well, red is reading on diode mode. Let's go to resistance. 37 ohms. Well, that's not so far out, really. The orange. Yeah, just climbing up. The yellow, 12 volts. Just climbing up. So if there is a low resistance, it's on the 5 volts. But 37 ohms on the 5 volts isn't particularly low if you think about it. If it was 50 ohms, then that would be drawing 100 milliamps. 25 ohms, 200 milliamps. So it's like 150 or something like that. And it's not unusual to have a resistor or some sort of load on here that actually puts a load on the 5 volts. But what I am interested in doing is measuring the 5 volts. So we'll put the analyzer back on again. Let's check again. Five volts. It's actually reading lower now. This is maybe giving a bit of load as well. I'm a little bit suspicious of that. That's still climbing up. That's still climbing up. So I'm a little bit suspicious of the 5 volt rail. Yeah, 17. Let's see if we switch this back on, if there's any voltage on this. No, there's 0 on the 5 volts. Let's check on the 3.3. Switch it back on briefly. 0. $12 volts. 0. So there's actually no voltage coming out of it apart from the 5 volt standby, which we know because this is telling us is like 5.1 volts. Okay. We need to look a little bit further. Disconnect the mains. Now I'll just check there is no voltage in the capacitor because obviously we've had power in this. Just flick it over. Okay. Make sure there's no high voltage in this. About 20 volts. And it's draining away. As you would expect, because the standby is running at least. Yeah. The voltage is low now in there. I'll just short that out. The mains is disconnected. Don't do this when there's a high voltage in the capacitor. You might just get a little spark. In fact, nothing you could even see. Yeah, less than a volt. Right, so there's something wrong with our main power supply by the looks of it. And I could smell something getting hot. Let's check a few things then. So let's think about it as well. We've had a short on the bridge rectifier. That means a massive current has been drawn through it to make it go short. And the most likely thing to do that is short circuit output devices. But they're not short now. So maybe the circuit from the positive of the bridge rectifier to hot ground through the output devices is now reading open because something actually went short then went open. Maybe there's a low value resistor in that circuit which is like a current sensor and maybe that's now open. Let's have a look. I suspect this has probably got PFC, which is power factor correction. Any power supply over about 300 watts normally has it. It has a big inductor here, which would be the PFC inductor. It has just looking down here, this device has 2 legs. That's a big diode, which would definitely be in the PFC circuit. It has what looks like a MOSFET or transistor under here, which would be in the PFC circuit, and then maybe the other one is on the switching output. I'll draw that just to show you what I think we've got, and then let's start looking to see if that's what we actually have. So then, active PFC. The way this works, we'll have the bridge rectifier, which we've just looked at. This is what was short on our board. We have the 2 AC signals coming in, voltages, yeah, 220 volts AC, and then we have coming out plus and minus. Now normally this would go to the large capacitor, which effectively smooths the voltage, and you end up with about 320 volts DC. But with active PFC, it's basically a voltage booster. So the negative end connects to hot ground, okay? The negative end of the large capacitor connects to hot ground, but the positive end doesn't connect to here. What we have is, we have an inductor, quite a hefty one, which is what I think I'm seeing here, okay? And then we have a diode, quite a high powered one, which is what I think I'm seeing down there with 2 legs on. And then we have the large capacitor. Okay, to hot ground. And from here, we have a MOSFET. Probably has a low value resistor in here, maybe, maybe not. And when I say low value, less than an ohm, you know, maybe 1 ohm, maybe it isn't there. And this goes to the PFC controller. The controller, power factor correction. And what this does, like all these type of inductor circuits, this switches on and off at a high frequency. Every time it switches on, it pulls current into the inductor, and every time it switches off, the magnetic field collapses. So while this is on, the field builds up. When this is off, the field collapses, and it effectively puts a higher voltage on this end than on that end when it does so. That boosts the voltage, this rectifies it, and it goes into this capacitor. The reason you end up with a higher voltage on this end, by the way, if you do wonder, this end will be at mains voltage, okay? So on this end of it, you have the positive half cycles. So you might have like effectively 220 volts or something here. When this switch is on, this coil magnetizes and it stores electrical power, current in the magnetic field. When it collapses, the current continues to flow in the same direction. So you've got the power coming in from the bridge and you've got the power from the magnetic field collapsing, both coming out at this end at the same time. And that's why you get a higher voltage here than this end. That's rectified, charge the capacitor, and this typically will have 380 to 420 volts in it. Ouch, don't touch it. Yeah, that's the PFC. Okay, then from the PFC, we now have the very high voltage, and we have our main primary of the transformer. Okay, if you look at ours, there's actually one power device here and one on that side, so there's two. Okay, that is definitely a diode. It has two legs. There's another one here, so this one almost certainly is that. Okay, the diode we know about, there's the large capacitor, and then the other two will be switching this transformer, which probably effectively has a center tap on it. Yeah, and we have two MOSFETs in here in one configuration or another, which drives the transformer. Coming off the transformer then, we have the various secondaries which power the 3.3 volts, 5 volts, 12 volts. Okay, so that's what we have. Now we need to figure out just what is wrong with it. I won't look at the output side of it yet. I want to see first, is there some problem in this area of the circuit? Okay, that's the first thing I want to check. One way to check that, by the way, would be to measure the voltage on this capacitor. If this has 380, 420 volts or something across it, then we know the PFC is working. If it has 320, we know it isn't. So probably that's the easiest way to test that. So let's do it. This will give us a sort of a go, no-go indication on the PFC. The large capacitor is here. This is the negative end, this is the positive end, and it could have up to 420 volts in it. Now, if you don't like working on high voltage circuits, and who does, really, the best way to tackle something like this is to actually attach crocodile clips, one or both of them. I'm actually going to put 2 on in this case. I could hold my meter on here and just use one hand. That's also relatively safe. I don't advise you to use both, just in case something stupid happens with your probe, it's been damaged, you never know. But you may find out violently, okay, or painfully at least if you're lucky, fatally if you're not. We can debate the semantics if you find out if it kills you. I think you probably realise before you die, okay? So I've actually attached both wires onto my multimeter. I'm reading about 0.9 of a volt in there. So I want to know what voltage I get in the PFC on this capacitor. Is it 320 or is it like 380? It's 270 something. That's low. So the PFC isn't running. That's the first thing we can say with this. We can also see the voltage drains quite quickly because something is discharging it. So we do know that the PFC isn't running. The PFC controller is almost certainly this one, because I can't see any other ICs on this side of the board. And often that PFC controller also drives the transistors in the main power supply, the large output transistors. Yeah, we can just check that. Let's see if we can find a data sheet for that one, and then we'll have a better idea of what we're looking at here. Okay, there is a part number on it. I don't think you can see it clearly on the camera. I just use my jeweler's loop, and it is CM6805BG. So let's see if we can find a data sheet for that. As I expected, this is a combined PFC and PWM controller. Okay, so this will be driving the MOSFET in the power factor correction circuit, and also the 2 MOSFETs or transistors in the main switching power supply, the 3.35 and 12 volt supply. We can see pin out, so we have pulse width modulation out, we have PFC out, we have VCC, so we can check if this is receiving any power. We will no doubt have some sort of enable, which will be coming from the other side of the board via an opto isolator. There's a current sense, so there's probably a low value resistor around here as well in the circuit. Okay. We have this PWM tri-fault. This is probably effectively the enable type thing. Okay. None of the rest of them sound like enable. There's another pin here to do with starting it up. Maybe that is also part of the enable. Let's see if we can find a typical application. I do notice here turn off PFC, PWM tri-fault. That can disable the PFC. It can detect shorts apparently. So this pin seems to be the one that controls this basically. there's something of an application here. And we have a typical application, which is just what I was looking for. So we can see bridge rectifier, large inductor. This is the MOSFET we were talking about, which connects down to ground or through a current sensing resistor, which is what I think this is. This is being driven from the PFC output on here, and that generates there via a fuse. No, I think it's just a bead inductor. This will generate the high voltage into the large capacitor, which is there. Okay. Other end of that comes back to, let's see. Yes, via a small resistor here. This will be current sensing, 0.33 ohms, as I mentioned, and brings you back down to the negative end of the bridge rectifier. So this is hot ground. Technically, this is hot ground, and this is hot ground via a low value resistor. But for all intents and purposes of measuring, it's probably really the same, unless you want to know what the current draw is. Okay, this could be what's getting hot, possibly, if we have a fault in this circuit. Then we have pulse width modulation out, which drives, in this case, one MOSFET. Okay, we have two on our board. I'm not sure if the other one is part of this circuit. I mean, I expect our circuit will look something like this. So that's what we have. And because this was short, I suspect something down here is blown and probably gone open now. So the most likely things are going to be this large MOSFET in the PFC circuit. We need to check that. And the ones on the output. So let's check all the output devices first. If we don't find anything wrong there, and there's also the diode, we'll check that. If we don't find anything wrong in the output devices, then I'll probably get the thermal camera and just see what's getting hot. I don't expect to find any short circuit devices on here, because that would cause the light bulb to come on bright, either in the PFC, if that MOSFET is. I mean, we may have a short in that diode, that wouldn't cause that to happen. I would imagine a short in either of these two, which I'm fairly sure we're both driving this, would also cause the light bulb to come on bright. Or something to go bang if you didn't have the light bulb in circuit. Let's see if we can remove this heatsink anyway with all the devices on, probably the easiest way. I mean, I could remove this inductor and this capacitor and unbolt them if I need to. As mentioned before, I don't have my vacuum desoldering tool working at the moment. So let's see if we can do it with Desoldering Braid and how easily or difficultly we can do it. Okay. I can see that the power devices, this is where the heatsink is, here. So I can see that looks like 3 legs there, maybe, or 1, 2, 3, let me see. A bit further in. Looks like one's there. 1, 2, 3. Looks like it needs focusing a little bit. So yeah, it looks like we have one there, 1, 2, 3. This is probably the diode, 2. And then the other 2 are back to back, somewhere in this area. Yeah, it looks like 1, 2, 3. And what's that? And what is that? You see it? A little bit of something there, a bit of metal on the board. That's obviously not a good thing to find. It's just, what is this? Well, it's not a bit of solder. It's not something I've got on the board. It's a little bit of wire. That's not a good thing to find in there. You don't suppose that was causing a problem, do you? I think we need to just try this again to be sure. I mean, personally, I don't think it was, but let's find out for certain. No, we still only have 5 volt standby. Let's see how fast this large capacitor is discharging now. I'll just disconnect the mains. Make that safe. Let's have a look. Actually, it took me a moment or three to just get my instrument camera back on, so this is probably discharged now. Yeah, it's down to like 12 volts. When the voltage gets low like this, you can just short it out. Obviously, make sure it's still not connected to the mains when you do it. Okay. Right, it's gone now. So back to this then. Let's see if I can figure out where these are. I think I can see it now. I think there's one there. 1, 2, 3. 1, 2, 3. Back to back. And the diode is there. Okay. I'll unsolder this with desolder braid. Let's add some leaded solder first. We'll probably get through a bit of braid doing this, but we've got to do it. Or it's best to do it. Although I don't think any of these are going to be short, I think we might possibly find something like a damaged gate on the MOSFET or something. Okay. This is the last bit of this braid, but I've got more of it. I had about 5 rolls left, so I then ordered a pack of 10 more, which arrived just around Christmas, so I'm not short of it. You need to make sure you keep this sort of stuff in stock. If you use a lot of it on the job, just add the cost of 1 roll to the bill. You know, this is the way to do it. In my case, I'm fixing most of this stuff for the channel, so you guys can learn how to do it. And those of you who pay me a little bit of money on Patreon, or other donations, thanks guys. Some of it goes into equipment. You'll see, and I hope you have seen, that I've upgraded my camera and audio system several times recently, and the other donations just keep me in stock with this stuff. Thank you. Fresh braid. So that one is definitely desoldered. I mean, I can see all the legs are actually free. I think that'll come out fairly easily. That one might be a little bit stiff, but I'm pretty sure it'll come out. We can go to the diode. Yeah, that's definitely free. You can use like a fan off a PC or something to blow the fumes away from you if you like. Okay, that's free. And then we have 2 more back to back a little bit further down towards the end of the heatsink. Here. Yeah, 1, 2, 3. I can see them. I can see them. Interestingly, the new solder wick I bought, which is this one, has a different style plastic holder to this one. The logo is slightly different. In fact, the whole design of this is a little bit different. They both say solder wick. I've often wondered if that is actually correct, like solder, yeah, or whether like these are copies and they've all just copied the same spelling mistake. Comments below, guys. Yeah, but this, from what I've just used the first bit of it, is working as well as the other stuff does. And that, my friends, is at the end of the day is what matters. Yeah, if it works the same. And that is certainly wicking that up very well. You can see it. Okay. Again. Go to the other side. Again. That one obviously wants a little bit more solder. The little SO23 transistors around here, try not to get too much heat into them, but I don't have a lot of choice really with this. I've got to do it. Okay. Yeah, that's definitely coming. Bend it the other way. Yeah. think that's 3, and then the last one is 3 legs here. Have somebody locally who's got 2 dogs and one only has 3 legs, and the dog's named Tripod. Yeah, it's actually named Tripod. I don't know if it was a rescue or had some incident when he was a puppy, I don't know, but yeah, Tripod. Okay. Right, I think that's clean. So, as well as that, there'll be at least 2 metal tabs holding the heatsink to the board. One of them I'm fairly sure is there, and the other one's probably there on the other side, yeah? Let's have a look. That's a big, heavy something or other. Right. I'm pretty sure that's one of them. And then the other one is down here, a little bit more flux on it. Having done this now, and I think this will come out, I've reminded myself why I bought the vacuum desoldering tool. It makes this much easier, that is for certain. And probably less expensive when you're taking the cost of consumables over a period of time. That one does not want to come. Let it solder. We'll have another go. Okay, now it came. Just get out of the way of all those fumes a moment. Okay. So, we have it. This is what I say about this stuff. Yeah, I start to price it off, doesn't it? That's why the vacuum tools are good. Okay, so that's now just wobbling completely freely, and I think if I have it right, this will literally just pull out of the board. Yeah, there you go. No stress or strain on it. And we can see now all the power devices. These look like they are probably MOSFETs, 18N something. Yeah, these will be MOSFETs. This one we know is a diode. This the same type. That's just a bit of glue on it. Yeah, it looks like the same sort of thing. Okay, yeah. Let's test these with the component analyzer. Yes, as somebody commented, oh, Mr. Guru, hi mate. Yeah, I can use the cheap component analyzer. I have one. I find the peak one just as convenient, and basically the two do the same thing. So, if you don't mind, I will use my peak analyzer. But you could just as easily use one of these things, €6-7, okay? I need to put a battery in it, but yeah, you could use that. This is probably just easier. But having said that, you could stick some leads into here with clips on like this and use it the same, okay? So excuse me guys, I'm going to use this one. Right, let's have a look. That's short, so we have a short here. That's the first thing we can say. Could be that I have the clips on badly. I've done that before now, so maybe that isn't the first thing we can say. Let's go again. No, we definitely have a short. Bend the leg up a little bit. Go again. Yeah. So that device is one of the main output ones, and that is short. Yeah, you can see it. That's that one, 18N, whatever. I'm surprised. I can't imagine them both being short. Let's have a look. Okay. Yeah, that one reads okay. That sort of makes some sense why the light bulb isn't coming on bright. Okay. If they were both short, I would expect it to just put the light bulb on bright or blow the fuse again if you didn't have that connected. One more time. just to be certain. Click back onto this one. Okay. Yeah, short. That's short. So that's one of the output MOSFETs is short. Let's look at the diodes. This is the diode in the PFC circuit. Reads okay. Yeah. This is the PFC MOSFET. Reads okay. So I think now we can say with good confidence we found what caused the bridge rectifier to blow. Question is, what else might be damaged? Let's have a look. Now we can see a little bit better. So we have down here a couple of fairly large diodes. Well, you need to check those. Basically, we need to check semiconductors in the area. Okay. Diode mode. We can see where they are. Turn it over. So one of them is here. Reads okay. Reads, yeah, that's just climbing up like capacitor is charging. Reads okay. Other one a little bit further down here. Does this go the other way around? Okay. Am I in the right place? That reads open. No, I don't think I was in the right place. I think it's here. Oh, there's a short there. Okay, so we need to look at this. Looks like that's the diode. Okay, short. So what's above it? Oh, I see. That's the resistor here. Low value resistor. And that reads open. Okay, so I think we're starting to get somewhere now. That resistor reads open. This is probably another good reason why it's not actually blowing fuses anymore. Do you see like something there? Maybe. Well, that is the leg of the resistor. It is intact, but it's like something happened. Yeah. Okay. So open circuit resistor and the diode short. Okay. That then comes into this area. I think I need to get this under a microscope to have a look now, see what we have around here. It all looks a bit melted, maybe. Yeah. Just before I do put this under the microscope, I've cleaned the flux off and it probably looks more okay now. I've removed the resistor. I've removed the short circuit diode because you probably can't take any sensible readings with this, and in particular the short circuit diode. So we can check those out of circuit. We can look to see what this resistor actually is as well. And then we can get the microscope. So the resistor then, red, yellow, silver. This is a low value resistor. If this was red, yellow, black, it would be 2.7 and no zeros following, so 27 ohms. The next one would be red, yellow, gold, which is times 0.1. So that's 27 times 0.1 is 2.7. And silver is times 0.01. So it's 27 times 0.01 is 0.27. So that's a 0.27 ohm resistor. This is the brown stripe, which means it's 1%. So that's quite a close tolerance resistor, which means you can't really replace it with a similar value. It's supposed to be that value, yeah. The diode, you see it's kind of blackened. I think that came from here on this resistor. And this, we'll just check now to make sure it is short and we're not seeing a short something else in the circuit, okay? It is possible the short is somewhere else. But no, that is short circuit. So the diode is hard to read the value of it. Look under the microscope as well at that. And let's have a look at the board. Here is our diode HER308. I probably have something like this in my stock. I can have a look. Possibly something like a 3 amp 800 volts. I'm not quite sure. We can look up the datasheet for that one. So that's the diode. The resistor we know about. We can clearly see the markings on it now if you couldn't clearly see them before. And we can see that something has happened here. Like this is arced over to something almost. It's like this red paint on here. Oh, we can see the resistor's cracked. There, yeah, big gap in it. So that needs replacing. I'm not sure I have the right ones. The short circuit MOSFET is this one. 13N500. 13N50DS. Let me check, but I'm pretty sure I don't have. No, I don't have, so I would need to order. So this is not going to be repaired on this video. If you want to see it fixed and you've had enough of this one, well, you'll have to wait. I don't mess around with this sort of stuff. If I'm going to replace it, 13N50, that's what's going to go in there, okay? Let's have a look at the rest of the board, see what else we can see. So this is where I removed the components. I want to have a bit of a look around here just to see. In fact, I can see a resistor already with a hole in it or something. That one. Yeah, that looks damaged. Let's have a bit of a look around here. So this is attached around where the short circuit device was. That's the one that was short. Okay, so if any voltage come in, that's where it's come in from. We have these devices which look like diodes. Let's have a look. In diode mode, you can see the meter. If I find a lot of damaged stuff around here, I may decide it's not really worth the repair attempt, but that one looks okay. H2F, I'm not sure if it's a transistor or a MOSFET, but we can have a look. So that's a diode junction. That reads short, okay. I don't know what this device is. I would have to probably look. It could just be a single diode, and effectively that is short, but then you'd expect that not the case because I have two separate tracks coming to here. Here is a low value resistor. 10 ohms. That reads almost. Oh, I'm on diode mode. Let's have a look. Ohms. That is now I'm now seeing the 10 ohms across there. Okay, so that maybe probably isn't short, it's just a low value resistor. This is almost certainly a bipolar transistor, so base collector emitter and a low value resistor there, 10 ohms. So that's probably okay. This looks like the thing's got a hole blown in it. It's reading open circuit. It's obviously 1 something 0. That's an open circuit one. So what's this reading? Let's go to diode mode again. Okay. Reads open that way. This reads open both ways. Okay. Can we see a port number on it? Another HA2. Okay. So we know from the other one this should be a diode. I can see the stripe on it now. And that's open. And that's coming directly from where this was shorted. That's gone open. This resistor was probably in parallel with it, which seems a bit strange for a low value resistor. That is open. That comes down to another one of these. So this is these H2F. We know from this one it's probably a bipolar transistor. Let's have a look. short. Yeah. Open. Nothing this way. How about this one? Junction, so we know that one is definitely short. That one reads like a transistor on both junctions. Is this another one of the same? Just alter the lighting a little bit, the angle. Sorry. Try to get it where I think I almost had something then. Okay, I can't read it exactly. I'm sure I could read it. What's it read like? It reads like it's short. That reads like a base emitter junction. That reads like a base emitter short if it's another bipolar. There's another one here. That reads a bit low, but it could be a resistor around here causing that. That reads open. Does I have a connection on it? Probably. Just get at it from the other angle. Reads open. Is that the same device as the one next to it? Zoom down a little bit. See if I can see it. H1 something, so it's different from the other ones. H1D. And this one next to it. Luke's, can you see it? So in the middle of it, something is definitely blown. That's gone. And we're now getting down towards the chip, which is here. Okay. There's some more diodes here. Let's have a look at these. But it looks like the damage has gone well back into the circuit. Yeah, there's another shorted one there. We know these are diodes. That one is okay. This one. H2, something or other. Well, that shows a bit of a resistance. That shows a bit of resistance. But the other way around, like it's a PNP transistor. Yeah, looks like it's a PNP. And it tests okay for a PNP. Looks like another diode. Reads short. Yeah, is that a diode? Stripe on it. Yeah, it looks like it. So we can say really with this that the high voltage damage has gone well back into the circuit. Okay, caused quite a lot of damage. I think then there's a bit of an important lesson with this, and that is probably knowing when to stop. Can it be fixed? Sure. I could probably get a bag full of these various SO23 devices very cheaply, I would think, and I would suggest if I'm going to fix it, I replace every single one of them in this area. The same with these diodes. There seems to be a couple of different sorts. I would replace every single one of them in the area. While they're removed, I would check all of the resistors to make sure they read okay, they are marked. May as well check across all the capacitors for any shorts. I'd probably find there aren't, but you never know. And I'd replace that chip. And if I do a sort of a mass replacement in the area, and I connect it up with a light bulb to make sure nothing goes bang, it might work. Yeah. But do you think it's worth it? I mean, personally, unless you think there's really something to learn by doing a massive replacement, and I can go and start looking up these SMD codes, and I'll probably find I can get a bag of 100 or 200 for €1 or something of each of the various types. So I don't think the expense is the problem. It's whether there's anything really to be gained by doing it. Yeah. But My opinion is no. I think you should learn the lesson, know when to stop. However, if you're one of these people who just can't stop, or you want to put me through like a world of pain, then get into the comments below and say, Rich, don't be a lazy sod and get on with it. Yeah. Okay, so I still think it was worthwhile. I think there was quite a lot learned during that repair attempt. And I actually hope you guys, for once, agree with me and say, yeah, leave that alone, mate. Go fix something else more fruitful. Yeah. Okay, let's hear from you. And I'll see you all soon on another Learning Electronics repair video. Ciao for now, guys.